Okay, so this is question 65. The 20 centimeter diameter disc in this figure can rotate on an axle through its center. What is the net torque about the axle? So first, I'm just going to define each of these forces. So this one is going to be force 1, and then this one's force 2, this one's force 3, and this one's force 4. So the equation that I'm going to use for all of these forces is going to be R equals diameter divided by 2. That's how you find the radius. So anyway, we'll come back to that. But we're going to do, so the torsion of number 1 is going to be the force 1 times the radius of 1 times the sine of the angle of 1. And that's going to be this one right here. So the force of this one's 30 newtons. The radius of this is going to be 5 centimeters. And we're going to times that by sine, and the angle is 45 degrees. And that's going to equal negative 106.06 newtons times 70 centimeters. And we're going to come back at the end and I'm going to calculate all of these into meters. But for right now, I'm just going to leave them in centimeters. So we'll just do it for the second one. So the torque of the second is going to be the force of 2 times the radius of 2 times the sine angle. So for number 2, it's right here. The force is going to be 30 newtons, and the radius of this one is going to be 10 centimeters, and it's going to be sine times the angle, and you can tell this is 90 degrees because it's straight that way, so the angle of 90 degrees. That's equal to 300 newtons times centimeters. And then we're going to move on to the third one. So T3 equals force of 3 times radius of 3 times the sine of the third angle. And that's this one. So the force is going to be 20 newtons. And we're going to times that by 5 centimeters, and the sine of, and this one's also 90 degrees as you can tell, and that's going to equal negative 100 newtons times centimeters. So then for this fourth one, it's actually equal to 0 because the distance on this is 0. There's not, like, none of it is in this part. So T4 equals 0. So now we just add all of these up. So I'm just going to add these up right here. And that is actually going to be equal to 93.94 newtons times centimeters. And then when we just convert this to meters, because meters is going to be 10 to the 2 centimeters, this is equal to 0.939 newtons times meters. And it's positive, which implies it's going in a clockwise direction.